Hey everybody, I'm recording this short video to talk a little bit about the assessment that you just took and the reassessment next week. And just want to make sure that you know what to expect so that you can take full advantage of the reassessment opportunity. So first of all, let's share my screen here. All right, so first off, if I scroll down to standards 6 through 11, assessment information, and open that up, you'll see that I posted a blank version of the assessment you just took and the key. So check out the key along with the comments and marks that I made on your assessment that I'll be sending back to you. And let me know if you have any questions at all about those. Right. But like I said at the beginning of the quarter, you're going to have the opportunity to bring your level of mastery up on standards where you want to improve. All right. So what I do in an online class is I wait till you've taken a couple of assessments so that I can kind of lump a lot of standards together to try to minimize the number of times you have to come in to campus to take assessments. So your reassessment opportunity for standards 1 through 11 is next Wednesday on May 7th. All right. You're going to come in just like on your other assessments, and they'll hand you a packet, although the packet will be larger than what you received yesterday and on your previous assessment, because of course there's twice as many standards on it. Okay, but don't worry, I've given you twice as much time if you need it. So you'll go in, regardless of what standards you want to reassess on, they're going to give you the entire packet. Okay. But that doesn't mean you need to do the entire packet. So I just do that to keep it simple so that they're giving the same thing to every student. But remember, you do not have to reassess on standards where you are happy with your score. You would only reassess on standards where you want some sort of improvement. So for my fake student account here, I'm going to go to grades. Okay. And just as a reminder, if the first thing that you see is something besides standard one level of mastery, standard two level of mastery, then you can always make it so that's the first thing you see by going and selecting assignment group to arrange by and applying that. All right, but I can look at all my scores here. And so here's the key. You absolutely want to reassess on any standards where you have a 0, a 1, or a 2, right? So that means not yet, novice, or developing. You absolutely want to reassess on those. Um, it's absolutely vital to reassess on zeros because you're not allowed to have any of those at the end of the quarter. Ones is also really important because you're only allowed to have a few of them. And then even twos you want to reassess on because you have to have a certain number of threes and fours, so proficients and experts at the end of the quarter in order to have a passing grade. So zeros, ones, and twos, absolute must to reassess on. And then I would say things that I have a standard 3 on. If I'm shooting for a solid A in the class, then you should also reassess on things you have a 3 on. All right. So now what I'm going to do as the fake student here is I would write down any of the standards that I plan on reassessing. And in my instructions to the testing center, I do let them know that it's okay if you have a little piece of paper that just simply says which standards you're going to redo. So you can't have notes or anything like that. But, just to remind yourself, oh, yeah, I need to do standard 1, standard 3, 7, and 11, right? So I could jot those down so I'd remember which ones to do. But for the ones that I'm happy with, then I just leave that blank. Okay. So in some ways, it's kind of unfortunate. It might waste some trees a little bit in the sense that if you don't have very many you really have to improve on, then you might leave a lot of the packet blank, and that's okay. Um, but you go in, and if you want to do all 11 standards, right? If you want to try and improve on every single one, then great. Then do all 11 standards. You'll have a 2-hour time limit to do that in. All right. So come in just like any other assessment, but you get to pick and choose which ones you reassess on. Definitely let me know if you have any questions at all about that process. Okay. So in terms of studying for it, you can always go back into old Newton assignments and rework problems. And also, both in the 6 through 11 and 1 through 5 assessment information, there's blank versions of the old exams. You could click on that, redo the old assessment, and then check your work and see how you're feeling about that material. Okay. The one other thing that I wanted to just mention, because it was a kind of a common mistake on the assessment, was on the calculator question, standard 8. So on this one, I'll just type in the function that you worked with. So 4x to the third and minus 9 x squared, and then plus 5. Okay, so I hit graph, and there's my function. All right, and I can see I have a maximum and I have a minimum. So if I go to maximum, it seems pretty clear that the maximum should be taking place right around an x value of 0. So if I go left bound, and then I go right bound, and I press enter, I'm expecting 0, but notice it says x is equal to 4.7817, but then it says e negative 7. So a lot of folks got, numbers here, and then you reported that number without this e negative 7. Okay. But here's the thing. We need to remember, sorry, I almost forgot to open this up. Give me one moment. Okay, share again here. So what we forgot is when we see something like that, what that really means is 4.7817 e negative 7 is scientific notation. Oops, sorry, I meant to actually write that out in proper scientific notation. So it should be times 10 to the negative 7. And remember what that means is that we're sending this decimal back 7 places. So 1, 2, 3, 4, 5, 6 zeros, then a 4, 7, 8, 1, 7. So when this happens, our calculator is just having trouble getting its algorithm to have it settle down on 0 precisely. So when you see something like this, you got to know that means 0. Okay. So we can see that we had a max. We had a max at x equals 0. And then you should have also gotten that we had a min at 1.5, I believe. So I'll go second calc, minimum 1.5. So left bound, right bound, enter. So 1.49999. Okay, what they really mean there is 1.5. Round correctly. All right, so we have our min and our max. Now, the last thing I just want to say is, because this can be kind of a tricky topic here, I'm going to take a picture so we can look at it more carefully. All right, so there's our function. Now, when it comes to increasing and decreasing, what you want to imagine is that you're actually walking along this curve as you get larger in the x. So walking from left to right, are you going uphill or downhill? So understand that your increasing and decreasing is going to be determined by endpoints that correspond to maxes and mins. So I can see that I'm walking uphill, right? As I go from the left to the right until I hit 0. So increasing from negative infinity to 0, but then I'm increasing again, right? Going uphill again from this minimum off to infinity. So from 1.5 to infinity. So just remember that what I'm asking for when I ask for intervals of increasing, these are your x values. That's all I'm asking you to report. X values. Doesn't matter what the Y values of these points are, right? I'm saying for what X's is the function going uphill. And then, of course, I can see it's decreasing between 0 and 1.5. Okay. The other thing I just thought I'd point out too, though, is the business of inflection points, right? That can be a tricky topic for us. So inflection points are the points where we switch from being concave down to concave up and vice versa. So remember, concave down and concave up, there's different ways of characterizing that. But the idea is that I'm concave up if I am continuing to get steeper and steeper and steeper as I move from left to right. And then, and steeper and steeper and steeper, as in my slope is becoming more positive. And then I'm concave down if the slope is becoming more, if it's decreasing, right? So, um, I should revise what I just said. Concave up when the slopes are getting bigger. So they might be in negative territory for a while, like right here, but then they start becoming positive. So they're getting bigger. Here, they're starting with positives, but then they're getting smaller and eventually going negative. So that's concave down. Okay. So one other way to characterize it, though, is concave up is like holding, a soup ladle, right? So kind of imagine this yellow section right here. That's my concave up. And then concave down is like putting the soup handle face down, like you're pouring it into the bowl, right? So what I highlighted in yellow is my concave up. What I highlighted in green is my concave down. And the inflection point is just this spot right here where it switches between the two. All I need you to do is just ballpark it, right? Different people are going to have different answers there. So I would call that about 0.75, halfway between 0 and 1.5. But I would accept anything that's kind of within a reasonable distance of that because we are just estimating our inflection points at this stage. But then once I have that, we can say concave down from negative infinity to 0.75, and then concave up. And once again, I'm talking about X values here from 0.75 to infinity. So I just thought I'd go through that because I feel like some kind of technical issues tripped us up a little bit. So hopefully that makes sense. And if you have any questions about it, reach out. I'm happy to help you during student hours or reach out via Canvas messaging, and I'd be happy to answer your questions. All right. I hope everyone has a great day, and we'll talk to you later. Thanks.